All right, guys, so welcome to your video for tonight. What we're going to talk about today is linear inequalities. What we've been doing so far are linear equations. So we've had an equation in either point slope, slope intercept, or standard form that has had an equal sign. Now we're going to take a linear equation, but instead of that equal sign, we're going to put an inequality symbol. So remember, there are four different symbols that we could have: less than, greater than, less than or equal to, and greater than or equal to. Hopefully you remember the difference in those. What we've done in the past is we have graphed something like x is less than -3. So there's only one variable, x, and we graphed it on a number line. So we took our critical value, which was -3, and we put an open circle there. It was open because there was no line underneath that less than symbol. So -3 is not included. Then we wanted all the values less than that, so we shaded to the left. And we said that each of the values in our shaded area, so any of these values that I'm marking and everything in between, was a solution to this inequality, whereas everything that was not shaded is not a solution. Well, that's exactly what we're going to be doing now, but now our problems are going to have two variables, an x and a y. This is going to answer that question of how are we going to get our picture in Desmos shaded, okay? So let's take a look at this. Here are 6 steps that you need to write down. This is step by step how we're going to do each of the problems. I'm not going to read them to you because I know you can read, so I want you to pause the video, I want you to write them all down, and then we're going to apply them in the next slide. All right, looking at this problem, we have y is less than 2x plus 3. So remember, this is similar to something we just would have had in the last couple weeks, y equals 2x plus 3. We know when we want to we know how to graph that. We start with our y-intercept, our b, and then from there we move whatever our slope is. So let's go ahead and identify our slope and our y-intercept. It's already in slope-intercept form for us, so we know our slope is 2, that value in front of the x. We know our y-intercept is 3. Now we have 2 more things that we need to figure out now, and that is, what kind of a line are we going to draw? Is it going to be a dashed line, or is it going to be a solid line? Remember from the steps you wrote down that it's going to be dashed if it's a less than or greater than, meaning there's no equal to sign underneath it. And it's going to be a solid line if it's one of those two inequalities, less than or equal to, greater than or equal to. So when we look at our inequality, it's less than, so I know that my line is going to be dashed. Okay, now to determine where I'm going to shade, we're going to see if we're going to shade above the inequality or below. Okay, now if the inequality is less than or equal to, you are going to shade all of the solutions below the line that you drew. If the inequality is greater than or equal to, you're going to shade the region above the line that you draw. Okay? So let's go ahead and get started. I'm going to start by plotting my 3, my y-intercept, just like usual. Then I'm going to rise 2 and run 1 because my slope is 2. I'm also going to go down 2 and to the left to get some points over here. Now before I draw in my line, I need to remember that it's going to be a dashed line. What do you think that dashed line means? It means the same thing as when we drew an open circle, that value was not included. Well, guess what? None of the values that are on this line here that I'm drawing in green, none of these points are included in the solution. So we're drawing a dashed line to show that they don't exist. They are not part of the solution. Now I know that it's because it is a less than symbol, I'm going to shade below my graph. So what would be below this line? That would be everything that is in this region below the line. So I take my pencil and I give it a good shading. What that means is any point that's in this region is going to be included or make my inequality true, any of these points. The points on the blue line, nope, they're not included. Any of these points, nope, not included because they're not in the shaded region. We can test this to make sure we're right. So I'm going to take this point right here, the origin, 0, 0. That's an easy one to test. And I'm going to plug it into my inequality, y is less than 2x plus 3. So for y, if I'm using the point 0, 0, I'm going to plug in 0, see if that's less than 2, what's my x? 0 plus 3. 2 times 0 is 0, 0 plus 3 is 3. Is 0 less than 3? Yes, that's true. So that point 0, 0 is a solution. It's in my shaded area, so I did shade the correct part. I could test one of these points right here that's in my not shaded area, and when I plug it into my inequality, I should get a false statement because it is not included in my solution. Okay, let's take a look at one more. Here I have an inequality that is in standard form. So the first thing that you need to do is get that inequality into slope-intercept. Remember, we cannot tell the slope of a line unless it is in slope-intercept form. Okay, so what I'm doing here is I am getting this into my correct form. I'm dividing everything by -2. Now remember, guys, remember from back a while ago, when we divide by a negative, what happens to our inequality? You've got to remember this. It flips. So instead of greater than or equal to, my inequality is now less than or equal to. -4x divided by -2, that gives me 2x, and 6 divided by -2 is -3. So this is now the inequality that I am graphing. Okay, so I'm going to plug in my slope, which is 2. My y-intercept, which is -3, is my line going to be solid or dashed? Because it includes that equal to sign, it's going to be a solid line this time. Since it's a less than symbol, go back to your notes. We know we're going to shade below the line and include everything. So let's get going. I'm going to graph -3, my y-intercept. A slope of 2 means up 2 over 1, up 2 over 1, down 2 to left 1. Now instead of drawing a dashed line, I'm going to draw a solid line, which means all of the values on that line are now solutions. They're included. So all the dots we drew plus all of these little ones in between, every one of those points would make my inequality true. Okay? Now I can't forget to shade. Since it's less than or equal to, I shade below my line. So I'm shading right in there. Okay? Now I'm going to test a point to make sure I shaded the right region. Notice that 0, 0 is not in my shaded region. So when I plug in 0, 0, which you can pick any point you want, I should get a false statement. Let's see. 4 times 0 minus 2 times 0, is that greater than or equal to 6? You can plug it into your standard form equation or your slope-intercept. It doesn't matter. So I get 0 minus 0, which is 0. Is 0 greater than or equal to 6? No, that's false, which means 0, 0 should not be shaded. Well, guess what? It's not. So that means we did, in fact, shade the right portion of the graph. You're either going to shade above your line or below it. So I could test this point to -3 and see if it's a solution. 2, -3 is right there. Is that going to be a solution? Yes, it is. It's going to be a solution because it's in the shaded. So again, you can plug that ordered pair into your inequality and test it and make sure. I'll let you do that and bring it to class tomorrow. Okay, we've got one more example to do very quickly. Here I'm given the inequality already drawn, and now I'm going to write what the inequality is. So for this problem, we are going to go ahead and identify the slope and the y-intercept. So the y-intercept of my graph is right here at -3, so I'm going to fill that in. The slope of my graph, let's find some points here so I can identify what the slope is. There's some good points on my line. Let's see, I rise up 1 over 2, up 1 over 2. So that slope is going to be 1/2. My line is dashed and it is shaded above. So what does all of this tell me? Since it's dashed, that tells me it's going to be either less than or greater than. No equal to sign. No equal to sign because that means it's a solid line. Now shading above, which one does that mean? That means it's got to be greater than. So my symbol is going to be greater than. So now I'm going to write my inequality using all the information that I've already identified, and that would be the inequality that matches with that graph. All right, that's it.